Hey guys, it's Trey back again with another video. And in today's video, we will be continuing on with our BMP file format generator. So in the last video, I talked about what a BMP file was, and I also talked about the structure of the file and what we will need to actually generate one. All right, today we'll be creating the simplest BMP ever by only utilizing 3 of the sections that we will need from the specification, and we will be generating a simple BMP that just has a blue square in the middle of the image and a white background. So the first thing I want to do is create a new folder to house our generator. So I'm going to say mkdir, and then I'm going to type in BMP. All right, so now this gives us our new BMP folder. And then I want to create our generator file. So basically, I want to say touch BMP, and then I'll do BMP gen.js. All right, so this is going to be our JS file. So I'm going to open this up. And the good thing about BMP is we're going to use uncompressed data, so we don't need to really install any packages or anything. The only package we're going to need is the FS package. The FS package will allow us to actually write the file to the disk. All right, so I'm going to go ahead and import that now. So now that we have that imported, I want to go ahead and create a couple of constants that we're going to use throughout this file. So we have a couple of constants here that we're going to use. So we have the file header. So we know, if you watched the last video, I told you guys that we're going to be using the BM file header. All right. And then we're going to create the DIB size. So the DIB is a section of the BMP file that we need to configure. And basically, the size is 40 of the one that we're going to be using. We're going to be using the bitmap info header, and that is always going to be 40 bytes long every time. All right. And then we'll have the pixel data offset, which is basically the file header length, which is going to be 14 bytes, plus the DIB size, which we know is 40 bytes. And that's why we have that here. And then also the name of the output file, which we'll just call auto.bmp. All right. So with that done, the next thing I want to do is go ahead and create some helper functions that's going to help us generate these sections of the BMP file. So we're going to have a couple of functions that basically help us to convert some numbers to a certain amount of bytes. And then we'll also have one that will convert this BM here into the actual Unicode values so that we can have the bytes that we will write to the file. All right. So our first one here is called 2 bytes int32, and this basically takes in a number and it will convert it to a 32-bit integer. So the reason we want to do this is because since we're writing this file from scratch, we need to be able to match how many bytes a certain part of the file is. So certain things are 4 bytes long, certain things are 2 bytes long. So we need to be able to convert it to that. So this will convert it to 4 bytes, and now I'm going to create a function that will convert a number to 2 bytes. All right, so this is called 2 bytes int 16, and this will convert it to a 2-byte integer. Any number that you put in there will convert it to a 2-byte integer. The next thing I want to do is create that function that will take our BM and turn it into Unicode characters so that we can write those bytes to our file. All right, so that's what this function does. It will take in a string and it will convert it to Unicode values. All right. So that's pretty much it for our helper functions. The next thing I want to do is actually create some functions that will help us to actually create these sections. So we need to create a file header section, a DIB header section, and also the actual pixel data. So the first thing I want to create is that function that will create the file header. All right, so now we have a create file header function that takes in the file size, which we will calculate. So this will be a calculated value, and it'll take into consideration everything that we need to know so that we can calculate this file size. The file size actually consists of the 2 headers. We have our file header, which is 14 bytes, and then we have our dib header, which is 40 bytes. So that'll be 54 bytes right there. And then we have the pixel data, and we'll have a 128 by 128 image. So we need to take that, multiply 128 by 128, and add that to the 54, and that will give us our size. All right, so once we get that size passed in, we'll just go ahead and create the file header. So I'm going to go ahead and pull this up just as a quick recap if you didn't see the last video. So the file header is it's going to take those 2 bytes, that BM, and then we'll have the size of the file, which will be 4 bytes long. And then we'll have these 2 things here, which are reserved. We'll just set those to 0. And then we'll have the starting address of the pixel data, which we know based off of the 2 headers. So that's what we're doing here. We're setting the file size, that's 4 bytes long. That's why we're setting it to 2 bytes int 32. And then we have those 2 things that were reserved, and we'll just set them both to 0, but they need to be 2 bytes long. That's why we call this 16. And then we have the pixel data offset, which is this here, and it also needs to be 4 bytes. That's why we call the int 32. All right. Now the thing that I want to point out is this reverse here. So when we create this array, which is this uint8 array, if you haven't seen this, this is basically just taking our bytes, our 4 bytes that we created here, and it's putting them into an 8-bit array. So basically, each byte right here is separated into its own element, and that's what we're doing here. All right, but this reverse is basically taking the bytes that we have and it's flipping them. The reason we're doing this is because the BMP file format uses little endian. So right now these bytes are in big endian format, and so we're reversing them to change them to little endian format. All right, so that's what we're doing here. And then this, we're just basically returning a uint8 array, so it's just an array of bytes, and then we're taking all of those out of there. So this 3 dots here means just get everything out of this array. That's basically what it's saying. All right, so from the top, we're creating a uint8 array, which is basically just an array of bytes. Then we're taking all of the bytes from the file header, which is 3 dots is doing. We're taking all those bytes and putting them in the array, and then doing the same thing for the rest of these. So we're just taking all the bytes and literally making an array out of all the bytes. That's all this is doing. All right, and this will create our file header for us. All right, the next thing we need to do is create our div header, and it's going to be the same thing. It's going to look exactly the same, but with different values. All right, so here's our div info header. As you can see, it looks very similar to up here. We are creating that byte array, and then we're taking the bytes of all of the different values that we need. So let me go ahead and run through this again here. So we're using this bitmap info header, and here are all the different values. So the first one is the size of the header, which is always going to be 40. And then we take in the width, the height of the image. These are signed integers. All right, and then we're taking the color plane, which is always going to be 1. The number of bits per pixel, we're going to be using 32. No compression, so we'll put 0 here. The image size, we're going to put 0 here. And then the resolution, I set it to the values that they used in the example down here. So they just use 2835, 2835. So I just decided to do the same thing here. No particular reason for that other than that's what they use down there. We have the color palette, which is going to be set to 0. So we just use the full range. And then also number of important colors will be 0 because we want every color to just be important. All right. So let's go ahead and take a look at that. So here we go. We pass in the div size, which we really don't need to do. We could just use this. So I think I'm going to change this up on the fly right now. So we'll take that out, and we can just say div size. And then what else do we have? Oh, we pass in the width and the height of the pixel. So basically this is just the pixel width and the pixel height. That's what that is. and also our bits per pixel. All right, and then we just set those in the proper places. All right, and then I have the comments here, so you'll be able to understand what's what. Okay, and then we also do the reverse on these. And then remember, these here are the height and the width are signed integers. So instead of using uint array, we're just using int8 array, all right? Because these are signed integers. And the same down here for the resolution. All right, everything else is unsigned. So we can use uint array, all right? So there's that. The next thing we want to do is create the one for the pixels. So now we're going to create our pixel data. This is going to look a little different because we're actually writing in the pixels to create a square. All right, so here's our create pixel array. The only thing we need to pass in is our width and our height because we know we're drawing a square. So this would change, like this whole function would change depending on what you're trying to draw. So we're creating the actual pixel data to make a square on the screen, okay? So the first thing we want to do is set up our pixel data array. So this is going to be a uint32 array because we have 32 bits per pixel. So that's why we're using a uint32 array here. And then we're setting the length as the width times the height. And that will give us our matrix, all right? The next thing I want to do is set the x bound and the y bound. This is basically just for our square. So we know where to stop drawing the square at, all right? And the next thing I wanted to do is just loop through the pixels, and we're getting an x and the y from the eye. All right, so we know where we are on the pixels. And then we're just basically checking if it's inside of the square. So this is basically just checking the square's bounds. If it's inside the square, then draw a blue color. All right, so once again, remember this is in little Indian format. So we're seeing red here, and then green here, and then blue here, and then this is alpha. All right, so FF is basically just saying draw it fully opaque. There's no transparency. Otherwise, we want to draw a white color, which I'm going to actually switch here to FF. All right, so this will be white. All right, and once we actually set all the pixels, we just return a new uint8 array of our pixel buffer. All right, because remember up here we have a 32 array, so we want to take that 32 bit array and turn it to a byte array. All right, so that's what we're doing here, and then we return that. All right, so with these created, now we can go ahead and actually write the function that will generate the image and also save it to the disk. All right, so here is our function that will generate the image, and we're taking a width, a height, and the bits per pixel, okay? So now we can call our create file header function, and we'll just pass in the size, and we'll get back our file header bytes. So it's just an array of bytes, that's all that is. And then we get our DIB header by passing in well, actually we changed that, so we're not doing that anymore. Yeah, so we just need to pass in the width, height, and the bits per pixel. So we do that here, width, height, bits per pixel. And then we have our pixel data where we can create our pixel array, and we're just passing in the width and the height. And this pixel data should represent a blue square with a white background. And last but not least, we just write our file to the disk by saying fs write file sync. We pass in the output name, so this is basically the file name. And then we pass in the data right here. So we're taking all three of our sections, and we're using that ... notation again to say get everything out of this 8-bit array. All right, so this byte array, and we do that for all three, and that basically writes all of our individual bytes to the file, and we're telling it that this is a binary file. So with this being done, now we can just call this function. So we need to call this function. I'm going to scroll to the bottom to do this. And we'll say generate square, and I said we're going to do a 128 by 128, and then we're doing 32 bits per pixel. All right, I'm going to save this, and then let's run it. So I'm going to say cd bmp so we can get in here, and then I'll say node bmp gen.js. We type enter, here's our file, and there it goes. auto.bmp. There it is. We have a blue square with a white background, and that's exactly what we're looking for. So I'm going to go ahead and pull up my file system so I can actually show you that this file is being recognized as a actual BMP image. So I'm going to come over here. Here's our BMP gen. This is the file we just created. If I hover over it, it says item type is BMP file. It also gives us the dimensions and the size, 64 kilobytes. So let's go ahead and open the properties, go to details. We see the dimensions here. We have the width, the height, the bit depth, which we all set. And then file name, file type, and all the rest of this stuff here. All right, so it recognizes it as an actual BMP file. So we literally just generated this from code. And we did that by learning the specification. You can do this pretty much with any type of file format. You can do it with file formats. You can also do this with protocols. So I might start a series where I actually do this with protocols, where we'll actually write out like the bytes and stuff to actually send like maybe an email or whatever you guys want to do. If you guys want to see that, let me know down in the comments, and I'll start a series doing that. But for now, I think I'm going to stick with these file formats, and we'll take a look at these. All right. So that's pretty much it for this one. We have generated the most simple BMP ever. That's all for this one. Thanks for watching. Like and subscribe to the channel and all that jazz. And I will see you guys in the next video.